Why does let fix the classic set timeout inside a for loop problem? Let fixes the classic set timeout inside a for loop problem because it creates a new block scoped binding for each iteration instead of reusing a single function scoped binding. What exactly exists is a loop block, a lexical environment for that block, a variable declared with let, and asynchronous callbacks that form closures over that variable. The order is strict. When the loop starts, a new lexical environment is created for the block. On each iteration, the engine creates a fresh binding for the let variable, assigns the current iteration value to that binding, and then schedules the asynchronous callback. Each callback captures a reference to the specific lexical environment created during its own iteration, not to a shared variable. The loop completes synchronously and finishes execution, but each preserved lexical environment remains reachable because the corresponding callback references it. Later, when the event loop executes each callback, variable resolution follows its own captured lexical environment, so each callback reads the value that existed during its iteration. The causal chain is let declared in block scope, new binding per iteration created. Callback captures that binding, loop finishes. Callbacks execute later and read independent values. This behavior differs from var because var creates one function scoped binding reused across all iterations, causing all callbacks to reference the same variable. For a software engineer, this guarantees predictable asynchronous behavior inside loops without manual closure wrappers. Let fixes the classic set timeout in a loop problem because it creates a separate block scoped variable for each iteration, so every callback captures its own independent binding.